Hey everyone, my name is Fedor Tcymbal. I am from Nizhny Novgorod, Russia, and I work in a company called Ride Innovation, which until very recently was called Mira, and my slides actually reflect that. I have a mix of all the new slides, and hopefully it will not distract you too much. So in our company, we work with a lot of customers in a lot of different areas. One of these areas is automotive area, so cars, electronics, and all this kind of stuff. And I in particular work with Android. And recently we released a new operation system called Android Automotive. And I'm going to talk about this today. So hopefully you'll be interested. Let's start. So for today, my agenda will look like this. Basically, I want to give you guys an overview of this new system, what it is, and how you can actually develop for it. So I'll explain what it is, how Android can work on a car, and specifically I'm going to talk about driver distraction guidelines because this is really interesting for me. And I'll just give you an overview what it means to be a developing applications for Android Automotive. And then we'll try to draw some conclusions and hopefully you'll like my today's talk. So let's go. So first, what is Android Automotive? I'd like to start with explaining what it isn't. It's not Android Auto. And I find it very often that it needs to be explained because there is obvious confusion between Android Auto and Android Automotive. And even Google documentation recently I found acknowledges this confusion and explains it. And I don't know why Google actually branded this new system very similar to their existing system, Android Auto. So Android Auto, as you probably know, has been around for a few years, like 5 years, I believe, something like that, even more. And it's actually a system which runs on your phone, not on your car. Your phone is connected to your car by a USB cable, usually. And everything is actually happening on the phone, and the car is just basically an accessory to your phone for Android Auto. It's just streaming the screen to the car, and that's it. Android Automotive runs directly on a car. It's an operation system. It runs on a car, and it doesn't require a phone or a cable. It's all you need basically is your car, and it will come with Android installed. So this is a huge difference. So what Android Automotive actually is? Well, it is Android. It is Android OS, and they actually call it AAOS now in Google documentation. I guess it's just they're still looking for a name, so they decide to use this abbreviation, and I'm sometimes going to use it too. Android Automotive is Android, and it's the same code, same repository. So it's not a fork, it's not a copy, it's not a completely different system. It's still Android, but with some enhancements which activates on build time. So when build images for your device, you can choose to build for Android Automotive. And after that, you can run this Android on a car. So for that, Google had to change a lot of things. And there are a lot of enhancements, and I'm going to talk about some of them. But today, there are already first cars with Android Automotive on board. And there are two cars from Volvo, they're all electric, both pretty expensive. So it's unlikely you're going to buy one of them soon, and they just were released this year. So Android Automotive is a brand new system. It's just starting, so it's like 2010 for Android. So it's really, you've seen the start of something big, I think. You can say, wait, why is it the start of something new? I mean, we've seen Android on car, right? Actually, there are multiple systems already, multiple vendors, car vendors, which give you a car, which can sell you a car with Android on it, not just Volvo. One example is, which is popular in Russia, is Yandex Auto. So how is it different? Why Android Automotive is different? Well, you see, Android Automotive is not a fork. So all these previous systems, they basically just people taking a standard mobile Android and modifying it for a car by themselves. And these systems, they basically live their separate lives. And they get updates when Yandex or some other company which produces them decides to give it an update. But Android Automotive would not be a fork. It would be just regular Android. So the day you get new mobile Android, every year, you'll get new Android Automotive. And on this Android Automotive, you will have Google Automotive Services, which is basically a replacement for Google Mobile Services. Google Mobile Services, that's something that includes YouTube or, let's say, Google Maps. And for car, Google Maps is actually a big thing because people love Google Maps Navigator. They're familiar with Google Maps. And have it run on your car without a phone is a big thing. And it wasn't possible before Android Automotive. And one more thing that will be available on Android Automotive is a Play Store. So all the applications that were developed for mobile Android, in theory, can run on Android Automotive. Not right now, literally, but in theory, you have this capacity which was not available on all other vendors. And the reason it's not available because all these previous devices, all these previous implementations of Android for a car were not certified by Google. So you couldn't run Play Store on them. Well, these implementations with Android Automotive will be certifiable. So they will allow Play Store and all the third-party apps. And the big thing here is that from day one, the system is adapted for a car. So Google actually created a lot of new features which not always available on all these other implementations. So what does it mean to have Android on a car, Android Automotive? Well, from Android perspective, car will be like list of properties, basically. It's very simple. Everything about the car, speed or a gear or any state of a door or something, this will be a property. And you can set this property, get this property, or subscribe to these changes in Android application. There is a specific API which allows you to do that. It's called Car Property Manager. Some properties you will be available to set or get. So what properties exactly will differ from car to car, from vendor to vendor, but the API will be the same. And properties actually have a very important property. They can be zoned. So every property can be attributed to either a window or a specific seat. So the way it works, let's say you write in an air conditioning application and you can subscribe to states of different doors and you monitor the states, and when they change, you change or set the properties related to temperature or power of air conditioning in different areas of the car. So actually air conditioning apps can be quite advanced with Android. This was just like basic thing, but I'm also going to talk about some of the subsystems that were changed. First one, actually, there are a lot of them. Like in the documentation, there's 15 enhancements listed for Android Automotive over standard Android. And I don't have the time to go through all this list. So I'm just going to concentrate on a couple of them. First one will be power management. And the reason I think it's important and interesting to talk about power management on Android Automotive, because power management of the car is quite different from power management on a mobile phone. First, car is constantly being turned off and on. I mean, mobile phone usually stays on unless it runs out of power, but you rarely power it off manually. With the car, it's all different thing. You park your car, you turn it off, you go somewhere for 5 minutes and run back, you power it on. But when it's off, it's not allowed to consume any power. You can say, well, it has this big battery, right? Well, the thing about the car is that it's supposed to run after like a year of inactivity. So it stays there and the battery still needs to keep the juice. So you cannot consume any power, so you cannot run in the background, right? So you need to really power off. But when the driver comes back, you actually need to power on fast because he wants to use a rear view camera. The driver wants to listen to audio immediately. He doesn't want to wait for a couple of minutes for the system to come up. So it's not like a mobile phone when you power it on and it's, loading for a couple of minutes. It wouldn't go with a car. So what you need is a quick boot into Android home screen. You need to have all the capabilities on, or at least most of the capabilities on fast. And you need to also restore your previous states of your apps. So if user was listening to music, he wants to continue to listen to the same song. He doesn't want you to forget what has happened. So very different requirements for an app and for a system. So to fulfill these requirements, first they had to reduce the power cycle and the whole boot up process of Android. But also they implemented a few new features. First one is called Deep Sleep. It's basically a kernel feature which allows you to suspend Android to flash, to RAM. And that allows you to actually boot up faster and to restore the states of the apps after boot up. Then there is a garage mode. That's basically a replacement for your idle timer on mobile device. So you probably know that if you leave your phone idle for like an hour, it will go to this idle mode and it will use it to install updates, run maintenance tasks, all this kind of stuff. So here you have the garage mode to replace this, and it's basically happening straight after you powered off the car. So it's like for 15 minutes after you turn it off, it will try to update and do this maintenance. And then there is a new API called Power Manager that allows apps to monitor the states of the power and to adapt. So, for example, here's some code just to show you that I'm not talking about this in theory. So it's very simple, basically, that you can first create power management using get car manager with a power service as an argument. And then you implement a car power state listener. And in this, you write on state change function. And in my example, I check that the state change to shutdown prepare. And if it does, then I save to RAM. In actuality, in apps that you write for right? This function is much bigger because you need to handle like 10 different states, and so this requires more complex state machine. But this is just an example of how you need to adapt to running your app on a car. Next big thing, very important, and I want to concentrate on it a bit, it's called driver distraction. And this is basically monumental mindset change for mobile developers when they come for car development. Because on a car, the first priority is a safety. The person is not going to just, not score in the game if you screw up. He can actually hit a wall or somebody because he's driving. You don't need to distract him a lot. And there are two mechanisms which Google introduced to handle this. It's basically driving states and UX restrictions. So there are only three states, actually: moving, idling, and parked. Moving is basically, well, you're driving, car is moving. Parked is, well, it's parked. And idling is kind of in between. So you're not parked, so, but maybe you just staying still in a gear, or maybe you moving really, really slow. So it's like transition state. And based on these states, there are multiple restrictions. I have a list of these restrictions on the screens. Things like no video or no text message. But this may be describe this logic a little better. So basically, if you're in a park mode, you're supposed to have no restrictions. So all the applications can run, all the activities can run. In idling mode, you get some restrictions, and in moving, you get maximum restrictions. So basically, your app is supposed to not distract the driver at all. So it needs to take as little attention as possible. The way system calculates these restrictions, and the reason why there is these two things, states and UX restrictions, is because first will be available only to the system apps, only to the privileged apps. So basically, let's say from a HAL, so basically from a car, we get like two properties. I was talking about properties. And these two properties are gear and speed. There is a specific service inside Android called driving state service, which calculates state based on this gear and speed, based on these properties. And there is an API, Car Driving State Manager, which is available only to privileged apps. And other applications will have to use other API called Car UX Restriction Managers. And this is public API, and this allows you to get all these restrictions. So you will not be allowed to learn if your car is moving or if it's idling. You just be told that basically you can't have text messages right now. And this is calculated based on other service, UX Restriction Managers. And the reason why there is two is because car manufacturers can actually develop different guidelines for different cars and for different countries. So in Japan, you can have specific, like, more restrictions, and in the Netherlands, you can have less restrictions, or vice versa, I don't know. But the way car manufacturers do this is by defining these XMLs, which basically give a rule of how to convert state into restriction. So, for example, this is the very simplest possible XML. So if you're in the parked state, okay, baseline, no restrictions, no distraction optimization required. You idling, the car switched from parked to gear. Okay, now we have some optimization, and this involves having no video and no configs, but you can still have text messages and all the other stuff. And then cars started moving. Speed became more than 0. Okay, fully restricted. All the restrictions are applicable. Now, at this point, your app or any app will actually be checked by the system if the activity, if it's in foreground. If the activity is running, it needs to have this flag called distraction optimized in manifest. So as a developer, you need to put it in your for every activity in your app, you need to put it if you want to run it on automotive. If you do not tag your activity with this flag, Android will basically just kill it as soon as any restriction become active. So basically, you have driving state change. System checks, do we need any optimization right now? Yeah, we need some optimization. Okay, is this activity optimized? Okay, then it can run. No, it's not optimized. No, it's we kill it. So basically, all the activities which are not optimized will be killed by a system, and this is not a good design actually to allow the system to kill your activity. So all activities in your app needs to be distraction optimized. So you need to handle the case when some UX restrictions became active, and you need to handle them in every activity of your app. Important thing to note, system only checks the flag. Whether or not you actually do something about these restrictions will be checked on the Play Store review. So the system will not prevent you from cheating in any way. You just can set the flag. But if you apply for Play Store review, if you want to put your app in the Play Store, they will probably check it, and it will be longer. The review will be longer for automotive apps. Now, again, some code example. Hopefully, you'll not be too bored by the code. What does it mean if you want to consume UX restrictions? So how do you handle UX restrictions in your app? First, you need to create UX restriction manager, and you need to implement restrictions changed listener in your app. And in this, you override a method called onUX restrictions changed. So in this method, you get these new restrictions and you handle them. For example, here I'm checking that if there is no video restrictions, so apparently my activity is playing video. So in my activity, I change, okay, now we get these restrictions. I need to handle stop playing video. So I basically need to stop playing video. So again, in every activity, you will get this if you want to have your app reviewed. And basically, the idea is that your app needs to reduce something like that. So if user was watching video and he decides to start driving, he'll basically get something. Sorry, you can't do this. You're driving now. So for app development, let's say you want to develop an app in Android Automotive, for Android Automotive. There are actually two types of developers that Google sees today that exist. First one is OEM developer. That's basically someone who works for car device manufacturer. So basically like me. And the good thing here is that this type of developers has access to all the privileged APIs. So we can basically play with Android Automotive. The second type is third parts developer, that's someone who develops for Play Store. And not all the APIs, a lot of them are actually private right now. So only public APIs, and there are a limited set of them. And since it's a new system, it's not actually even standardized what APIs would be available, because there are not a lot of cars yet. And so as new cars become available, each car will be slightly different from each manufacturer. And functionality that will be available to third-party developers and to OEM developers actually will be different. But I expect that it will normalize at some point as the system becomes more and more mature. So I was saying that this is quite a different mindset for a developer. It's also quite a different mindset for UX designer, because you need to create a design which follows different principles from the ones that are normal for mobile phone. On the mobile phone, you want to keep the user engaged. You want to keep him interested in your UI. And here it's opposite. You want driver to be focused on the road. You don't want him to be distracted by your app. So you do this by following the new design principles. That Google provided to all the designers. And I have some example here, which I'll try to explain. So first, keep information current and glanceable. So it needs to be relevant to the user. It needs to be relevant to the driving. So for example, here we can see that there is low oil, and this is important. And then we miss some calls. So this is basically an example of notification, but basically the whole UI needs to be like this. You need to encourage hands-on driving. So user should not take his hands off the driving wheel. This mostly means using voice commands and Google Assistant. So I don't know what percentage of developers use voice commands in their apps right now, but on automotive, on a car, this is priority. So there is some mechanism which helps with that, but basically you need to keep this in mind when you develop that. Want to have, and basically must have voice commands, or user will basically crash a car when he's trying to navigate through your menu with a finger. And this flows in the next one, prioritize driving tasks. So basically, focus on something that's related to driving, like low oil or any notifications about the car. They take priority, and discourage any distractions. So you don't want to have anything that you won't have in a mobile app. Basically, that draws attention, like some animation or something jumping on the screen saying, look at me, look at me. That is something you absolutely want to avoid on a car app. And there are visual design principles to follow up with that, because you want to have user just glance and get eyes back on the road. He needs to be able to see all the information really fast. So all the content needs to be easy to read. So it shouldn't be very long. The font should be big. It needs to be easy to touch. UI elements needs to be consistent. They don't need to jump. So yeah, visual design is very different here too. Now, let's say you are a second type of developer, so Play Store. Mostly the idea right now is that you probably already have some app for mobile and you just want to convert it to automotive. Or you develop a new app and you want it to be available on mobile and on automotive. So that means that you probably need, there's a guideline which describes how you do that by having two modules in your app. So basically you have a shared module with logic, and you have mobile module with mobile specific UI, and you have automotive module with automotive specific UI. This is very basic, and I'm not going to go into details here. And today, the only type of app which is actually supported for automotive Play Store is media app. So basically music players and podcasts and all this kind of stuff. This is the only type of app that right now you can develop for Play Store. This is probably going to change very soon. I think the next step will be something around navigation, parking, and charging apps. And the reason I think that because I don't know if you heard, but very recently Google released a new library for Android Auto, which allows you to develop exactly these types of apps for Android Auto. So we should expect that the same will be available to Android Automotive very soon. Now, let's say, okay, you want to develop for Android Automotive. What will you use as a platform? How will you test your app? How will you see how it looks? What will you run it on? If you're OEM developer, you probably get some hardware from your employer. So car manufacturer will have their specific hardware for you, so you don't need to think about this too much. If you Play Store developer, you basically have two options. First one, if you want real hardware, you can start Android Automotive on a Pixel 3 XL or Pixel 4 XL. Just these two pixels. And it will not look very nice, but well, you can still use it. And if you want real hardware, that's basically your options. That's probably easiest to get. And of course, you can use emulator, and this will probably be the best option for most of the developers because it allows you to test. You can see it's a little small, but you can see here you can say parking and car speed, so you can test all these UX restrictions, how it works. So yeah, the emulator will probably be what most of the developers use right now. Now, let's draw some conclusions. Let's finish up. First, a quick summary of what I've told up until now. Android Automotive is an Android. So it's an Android, it's not a fork, it's the same code, but it is enhanced to run on a car. There are a lot of changes that Google did to make it possible. So it's quite different from regular Android, but developing for it is actually not that different. You can adapt rather fast, but you will need to change your mindset significantly because your app needs to be not distracting. So driving distractions and safety is a priority. Don't distract the driver. But this is just one aspect of it, and I just scratched the surface. I didn't have the time to talk about all the details. So if you're interested, please, there are a lot of information already available on Google documentation, and I was thinking about putting the links here if you were interested, but I eventually decided that, well, you can probably find them yourself, and I'm not going to direct to some specific path. But there is a reason to learn Android Automotive, actually, and I think for me, Android Automotive looks very promising. There are 1.4 billion cars on the roads right now. So that's a lot of devices that can run Android potentially. And we should expect that Android Automotive will take a big chunk of this market, like it was with Android TV, for example, where Android took, big percentage of the market. So big percentage of smart TV devices run Android Automotive today. And the reason why Android Automotive will probably do that, because it has the same killer features. It has Google Maps, it has Play Store, it has all this big developer community of Android developers, and we're all part of it. And we can see that market is actually very interested in Android Automotive. There are a lot of vendors today besides Volvo. So General Motors, Nissan, others who actually actively developing for Android Automotive right now. And this indicates bright future for Android Automotive, in my opinion. But this is exactly the future, because if you want to develop for Android Automotive today, you either have to work for a car manufacturer, or you maybe want to adopt your existing app using emulator, but it needs to be media app, and most of the app developers will not want to do it right now. But in a couple of years, I think Android Automotive will become big as we get more cars on the roads, as more and more APIs become available, more types of apps. You will want to cover this billion of devices out there with your app, and maybe it's a good idea for every mobile developer, for every Android developer to learn Android Automotive. So that's it for me. Thank you very much. I hope you enjoy the talk, and I guess if you want to ask a question, you can do it through my contacts here on the screen. Thank you, and goodbye.